In this lesson, we'll take an introductory look at data interpretation questions on the GRE. These questions feature some sort of visual information, such as a graph, chart, or diagram, which you must use to answer regular multiple choice questions, or multiple choice questions with more than one correct answer, or numeric entry questions. Now, within each quantitative section of the GRE, you will typically encounter one set of data interpretation questions. These questions are grouped together, and they all refer to the same information source. So when you come to the first data interpretation question in the set, you'll see a message like this telling you that the upcoming group of questions are all based on the same data. Now, in general, you should expect to see 3, sometimes 4 consecutive questions. The nice thing about data interpretation questions is that they do not require any knowledge beyond what you already need to know for the other math questions on the test. In particular, data interpretation questions place a strong emphasis on real-life math concepts, such as statistics, percents, ratios, and probability. In other words, these questions require you to perform the kinds of mathematical analysis that graduate students typically perform on data. Now, in addition to possessing knowledge of statistics, percents, and so on, you do need to know how to interpret visual information in the form of tables, graphs, diagrams, and so on. Now, most of these forms will be familiar to you since you see them all around. For the less familiar forms, such as scatter plots and Venn diagrams, we've created individual lessons on those topics. Now, an important feature of data interpretation questions is that the visual graphics, such as bar graphs, circle graphs, and line graphs, are always drawn to scale. This means we can often read, estimate, or compare data values by sight. Finally, when it comes to effectively managing your time on the quantitative sections of the GRE, you should allot about 2 minutes per data interpretation question. Alright, that concludes this lesson on the basic components of data interpretation questions. In the next lesson, we'll examine strategies for answering these kinds of questions. In this lesson, we'll examine the strategy for handling data interpretation questions. Now, when you encounter a data interpretation question, the first step is to examine the given data to understand the big picture. In other words, take the time to learn what story the information is telling you. Now, the goal here is to get a general feeling of the big picture, so don't spend more than 10 to 15 seconds on this task. Now, while examining the data, there are some specific things to watch out for. First, be sure to read any text that may accompany the data. In some cases, this text explains crucial aspects of the given information. You should also pay close attention to the units of measurement used. For graphics that have axes, carefully read the axis labels and determine whether each axis begins at 0 or some other number. On a similar note, determine whether the values increase at constant intervals or in some other manner. Also, as you examine the given data, see if you can identify possible trends and relationships. For example, does the data spike at some point? Does it level out? Is there a cyclical nature to the data? And so on. Also, does one factor seem to influence another factor? For example, it may be the case that as one value increases, the other value decreases. Alright, so those are some things to watch out for as you try to understand the story that the information tells. As I said, you should not spend more than 10 to 15 seconds on this step. This step is merely intended to provide enough context to help you understand the questions that accompany the information. This brings us to our next step. Once you have a general idea of the data's big picture, your next step is to carefully read the question. As you do so, beware of any discrepancies between the units in the text and the units in the data. For example, the question may concern the occurrence of some incident each week, but the data may involve the occurrence of some incident each day. This is a common trap on the GRE. Finally, once you fully understand the question, your next step is to check the answer choices before performing any calculations. There are 2 reasons for this. First, the answer choices will indicate the correct form of the answer. For example, if the question asks you to find a certain probability, the answer choices can be expressed either as decimals or as fractions. So if you don't know the correct form of the answer, you might unwittingly perform more calculations than are necessary. Now, the bigger reason for checking the answer choices first is that the answer choices will indicate the degree of accuracy required. For example, in this question, answer choices that are very spread apart, like this, suggest that you can be very aggressive in your estimation. Conversely, answer choices that are tightly packed together might require you to be more precise in your calculations. So you won't know how accurate you need to be unless you check the answer choices first. Okay, so that's the general strategy for tackling data interpretation questions. Now let's examine some additional tips to consider. The first tip is estimate whenever possible. Remember that the GRE test makers are not interested in your ability to perform tedious calculations, and in most cases, the answer choices will allow for estimation and rounding. So don't automatically assume that you need to use the on-screen calculator for a question. The next tip involves an important feature of data interpretation questions. That is, the visual graphics, such as bar graphs, circle graphs, and line graphs, are always drawn to scale. So in many cases, you can visually estimate or compare the data values. The next tip to consider is, be sure not to confuse numbers with rates or percents. This is also a common trap on the GRE. So for example, if company A here experienced the greatest percent increase in revenue, this does not necessarily mean that company A also experienced the greatest dollar increase in revenue. Okay, that concludes these tips. Let's summarize. In this lesson, we learned the strategy for tackling data interpretation questions, and we learned some additional tips to consider. On the GRE, you'll be expected to analyze information in the form of a Venn diagram. So in this brief lesson, we'll examine how Venn diagrams work. To begin, a Venn diagram is a tool used to show shared characteristics among a population of people or things. For example, consider a population of 15 employees at a company where some people have an MBA and some people have worked at the company for more than 10 years. At a glance, this Venn diagram shows us the breakdown of employees based on these two characteristics. So, since there are 5 people inside this blue circle, we know that there are 5 people who have worked at the company for more than 10 years. Similarly, since there are 8 people inside this purple circle, we know that there are 8 people at the company who have an MBA. Also, these two symbols inside both circles represent the 2 employees who have an MBA and have worked at the company for more than 10 years. These 4 symbols that are in neither circle represent the 4 employees who have neither an MBA nor have worked at the company for more than 10 years. On a similar note, these 3 symbols that are in the blue circle but not in the purple circle represent the 3 employees who have worked at the company for more than 10 years but do not have an MBA. Okay, so that's how these diagrams work. It's also important to note that we can extend these principles to include more than 2 circles. For example, consider this Venn diagram representing some characteristics of the homes in Haverford Estates. The characteristics for this diagram are having a garage, having air conditioning, and having a pool. Based on this diagram, see if you can determine the total number of homes in Haverford Estates, the number of homes that have all 3 features, and the number of homes that have exactly 2 features. Now you might want to pause this video and answer these questions before continuing. Alright, let's see how you did. First, the total number of homes. Well, to answer this question, just count how many symbols there are. There are 21 altogether, so there are 21 homes. Next, the number of homes with all 3 features. Well, the homes with all 3 features are here, inside all 3 circles. There are 5 altogether, so there are 5 such homes. Finally, the number of homes with exactly 2 features. We'll answer this one in parts. We'll find the number of homes with a garage and a pool only, the number of homes with a pool and air conditioning only, and the homes with a garage and air conditioning only. Beginning with homes with a garage and pool only, we can see that there are 2 such homes. Moving on to homes with a pool and air conditioning only, we can see that there is just 1 such home. Finally, when it comes to homes with a garage and air conditioning only, we see that there are no such homes. So altogether, there are 3 homes that have exactly 2 of the 3 features. If you correctly answered these questions, then you know everything there is to know about Venn diagrams on the GRE. On the GRE, you may be expected to analyze information in the form of a scatter plot. So in this lesson, we'll examine how these graphics work. To begin, a scatter plot is a useful way to visualize information about individual members of a population, where each member has two variables associated with it. For example, let's say we have a population of 20 male employees, and we want to see if any relationship exists between an employee's weight and his height. Well, a scatter plot is a great tool for displaying this kind of information. Here we'll label one axis with a range of possible heights, and we'll label the other axis with a range of possible weights. Once we collect the information about the heights and weights of all 20 employees, we can display it on our scatter plot. Here each dot represents a particular employee. Let's take a closer look at this employee. The position of this dot tells us that the employee is 67 inches tall and weighs 140 pounds. What about this employee? Well, from the position of this dot, we can see that he is 75 inches tall and weighs about 205 pounds. Now from the scatter plot, we can see a relationship between the employees' heights and their weights. For the most part, the taller the employee, the heavier the employee. In more general terms, we can loosely say that as one value increases, the other value also increases. When this occurs, we see that we have a positive correlation. Now, as you can see, the relationship is not 100% perfect. For example, this dot represents an employee whose measurements don't fit very well. Although this employee is the second tallest in the group, he's also one of the lightest. So as I said, the relationship is not perfect. Now later on we'll learn about the strength of a correlation, but for the time being, just recognize that there appears to be a relationship between the height and weight among these 20 men. Now when it comes to scatter plots, we must be familiar with the term trend line, also known as the regression line. This is the line, or possibly curve, that best fits the data. In fact, the trend line also goes by the name of line of best fit. So if we were to draw a line that best fits the given information here, what would it look like? Well, it would look something like this. Now please note that there's a somewhat complicated algorithm for calculating the trend line, but we don't need to know how to perform this calculation for the GRE. Just know that if a scatter plot includes a trend line, then this is the line that best fits the given data. Now I should also mention that on occasion, a scatter plot may include a second line. The parameters of this line will be defined somewhere in the question. For example, let's say that this purple dotted line represents what Dr. Jones believes to be the perfect weight for a given height. So if a dot lies directly on the purple line, then according to Dr. Jones, that person's weight is perfect for his height. Given this, a question might ask you to use the purple line to determine how many employees weigh less than their perfect weight. Well, here's one such person. This man is 67 inches tall and weighs 140 pounds. However, according to the purple line, the perfect weight for a man this tall is about 147 pounds. So according to the purple line, this man weighs less than the perfect weight. In fact, since all 5 of these men are positioned below the purple line, we can conclude that there are 5 men who weigh less than their perfect weight. Alright, now let's examine a different scatter plot. In this scatter plot, we'll show the elevation and the average annual temperature of 14 different towns in a certain country. See if you can predict the pattern here. What kind of relationship do you think exists between the elevation of a town and its average annual temperature? Did you picture something like this? We can see that as a town's elevation increases, its average temperature decreases. When we have a relationship in which one value increases while the other value decreases, we say there's a negative correlation. Now, while not all scatter plots on the GRE will feature a trend line, I'll add one here for good measure. Okay, let's examine one more scatter plot. In this one, we'll examine the heights and the GRE scores of members in some group. What do you think this one will look like? Well, let's say it looks something like this. Here there doesn't seem to be any relationship between the two variables. In these instances, we can see that there's no correlation, or that the correlation is negligible. Alright, before I end this lesson, I'd like to talk a little bit more about the strength of a correlation. In general, the closer the dots lie to the trend line, the stronger the correlation. For example, this scatter plot indicates a positive correlation between two variables, and this scatter plot also indicates a positive correlation. However, since the points in the second scatter plot are much closer to the trend line, we say that the correlation here is stronger. Similarly, this scatter plot indicates a negative correlation between two variables, and this scatter plot indicates a stronger negative correlation. Now, as an aside, please note that we can say that one correlation is stronger even when the trend line is missing. Alright, finally, this scatter plot indicates a negligible correlation. Okay, that's pretty much all you need to know about scatter plots for the GRE. Let's summarize. In this lesson, we learned that scatter plots can be used to analyze relationships between two shared variables in a population. The trend line is the line that best fits the data points in a scatter plot. The closer the data points are to the trend line, the stronger the correlation. A positive correlation means one value increases as the other value increases. A negative correlation means one value increases as the other value decreases. And a negligible correlation means that there is little or no relationship between the variables.